my name is Susale Mohana, as you might know by now. I taught A-level maths for a long time. I'm just going over some of the aspects of A-level pure maths to help students like you revise. So in the last two lessons, I showed how to get the formula for sine of A plus B and A is cos of A plus B and deduce the same for A minus B. And then I spent some time doing some questions on how to apply them. So we continue in the same with the same theme rather. So I will do further examples on compound angle formulae. I did example 1 and 2, I think, so let me do example 3. The numbering doesn't matter, it's the example that's important. Suppose you're given that cot of A plus 45 or theta plus 45 equal to 3, 2 theta, find cot 2 theta. And hence find the range of values of theta find the values of theta, find the values of theta in the range 0, 360 inclusive, for which cot of 2 theta plus 45 equals 3. Ooh! I just made up that question based on the question I remembered somewhere else. So therefore, there is no formula for cot of A plus B, but we have a savior. Cot is 1 over tan, tan is 1 over cot. So can I say therefore, tan of 2 theta plus 45 is equal to 1 over 3. Now we are on familiar grounds. So I can say tan 2 theta plus tan 45 over 1 minus tan 2 theta tan 45 is equal to 1 over 3. Remember, tan 45 is 1. So it becomes 3 times tan 2 theta plus 1 is equal to 1 minus tan 2 theta. So 3 tan 2 theta plus 3 equal to 1 minus tan 2 theta. 4 tan 2 theta equal to minus 2. So I end up getting tan 2 theta equal to minus half. So cot 2 theta is equal to minus 2. You are asked to find the value of cot 2 theta. Cot 2 theta equal to minus 2. That's how you apply the formula. But then I arrived at this based on tan of cot of 2 theta plus 45 is 3. I need to solve it. So instead of solving this, I can solve cot 2 theta equal to minus 2. Instead of solving cot 2 theta equal to minus 2, I can solve tan 2 theta equal to minus half. So I need to solve that equation, which we did a couple of lessons ago. Let me go over the information as we do it. So tan 2 theta equal to minus half. First job is find PV as tan inverse minus half or arc tan minus half. Where's my calculator and my glasses as usual? Okay. Shift tan minus 0.5 minus 26.6. So PV is minus 26.6. Remember I told you yesterday, you write the general formula first and then you solve. So therefore, 2 theta equal to 180 n minus 26.6. So theta equal to 90 n minus 13.3. And I want from 0 to 360 inclusive. Put n as 0, theta is negative, outside the range. Put n as 1, 90 minus 13 is 77, 76.7. This pen is giving up. Okay. Then put n equal to 2, theta will be 166.7. Look, 180 minus 13.3, but I keep on adding 90. Put n equal to 3, 160, so 256.7. Put n equal to 4, 256 plus 90, 346.7. When you put n equal to 5, outside the range. So your answers are theta equal to 76.7, 166.7, 256.7, 346.7. Those are the values of theta for which tan 2 theta is minus half. So for which cot 2 theta is minus 2, for which cot of 2 theta plus 45 is equal to 3. Memory, good. Let's take another example. I have seen a question which I am going to do now, similar to this, in one of the past A-level papers. I can't remember which year. It rings a bell. Right? Something like if sine of theta minus alpha equal to 2 cos theta plus alpha, where tan alpha equal to 2, find tan theta. First and foremost, I have a theta minus alpha and a theta plus alpha, which are two different angles. And over and above that, I have a sine and a cos. So, first let us expand the sine and cos. So, can I say sine theta cos alpha minus cos theta sine alpha equal to 2 cos theta cos alpha minus 2 sine theta sine alpha. At least now I have taken care of theta plus alpha. At least I have single angles now instead of two angles combined together. But I want tan theta and I know tan alpha. That means I want tan. Remember, I use this when I prove tan of A plus B. If you want tan, divide sine by cos. So I divide everything by cos theta cos alpha. So what do I get? Sine theta cos alpha divided by cos theta cos alpha. Cos alpha cancels. I am left with tan theta minus cos theta sin alpha divided by cos theta cos alpha. Cos theta cancels. Sin alpha over cos alpha is tan alpha equal to cos theta cancels. Cos alpha cancels. I am left with 2 minus sin theta divided by cos theta is tan theta. Sin alpha divided by cos alpha is tan alpha. I have that answer. So now, even though the question had sin and cos, I managed to get everything in terms of tan. That's a standard technique. But I know tan alpha is 2. So I can say tan alpha tan theta minus 2 is 2 minus 4 tan alpha. Oh, 4 tan theta. So this pen is gone. Let me look at the third pen now, which is, so 5 tan theta equal to 4. So tan theta equal to 4 over 5. That's the fourth example I'm taking. Clear? It's a question, the whole idea again is for you to get used to various ways and means of solving such equations. Suppose I had remember I told you every time prove an identity, do examples, equation, solve. So I've done examples, now I'm going to do equations to solve. To sine solve for minus 180 less than or equal less than x less than or equal to 180. Number 1. 2 sine x plus 30 equal to cos x minus 30. Cos x plus 30. No, x minus 30. We'll take up the other one later. I can't do anything much. The only thing I can do is get a tan, because this will have sine and cos, that will have sine and cos. So this is 2 sine x cos 30 plus 2 cos x sine 30 is equal to cos x cos 30 plus sine x sine 30. I've applied the formula for a plus b. Well, I can group all the sine x's, substitute the value of cos 30, substitute the value of sine 30. Let's think for a minute. I have a cos, when I divide by cos it will go away. I have a sine divided by cos gives me tan. So, I'll divide that by cos x cos 30. I divide that by cos x cos 30. I divide that by cos x cos 30. I divide that by cos x cos 30. Meaning, do not blindly substitute the values. Think for a minute. Cos 30 is go. I get 2 tan x plus 2 tan 30 equal to 1 minus tan x tan 30. From there, I can make tan x the subject. So 2 tan x plus tan x tan 30 equal to 1 minus 2 tan 30. So what is tan x? Times 2 plus tan 30 equals 1 minus 2 tan 30. So tan x equal to 1 minus 2 tan 30 over 2 plus tan 30. If I want, of course, sometimes they say show that is root 3 something. But he just says solve, so you don't have to substitute the values. I can use a calculator. So have you understood so far? So whenever you have equations like this, expand using the compound angle formula and then divide everything by cos cos. So to get everything in terms of tan, then make tan x the subject. So I will rub this off, except the last step, which I will rub later. At the moment, I will rewrite it so that's where we start from, because now double angle formula is over. So I have got tan x equal to 1 minus 2 tan 30 over 2 plus tan 30. As usual, I find what is PV. So open bracket 1 minus 2 times tan 30 close bracket, another bracket, divided by open a bracket 2 plus tan 30 close bracket equal to that. Then shift tan answer. Okay. Minus 3.43. Ooh, so small an angle. PB is minus 3.43. So x equal to 100. I just made up a question, so I didn't expect that to be so small. N equal to 0, outside the range. N equal to 1, 180, 175, 174.57 or approximately 174.6. And then put N equal to 2, 354.6. And N equal to 3 is again outside the range. So your answers are 174.57 or 0.6 and then 354.6. See, an equation can come like this. But again, ultimately, we go back to the various methods of solving, whether it is 2x or x plus 4, the method would be the same. Let me just take one more example if I can. I think I need these later, so I'll prove them now or I'll prove them later. I'm just wondering. Just proving an identity. Let us see this. Show that tan of A plus B, no, sine of A plus B over cos A cos B equals tan A plus tan B, which in 3 examples I think I have proved. This is not solving, this is now identities. Remember I told you yesterday, single angles, formulae, standard identities, equations, prove identities, compound angles, standard formulae, questions, equations, identities, double angle, same thing, half angle, same thing. In other words, there's so much, this is a teacher as a field day asking you questions on this, because you can do so many questions on this. So start with the left hand side or the left side. It is sin A cos B plus over cos A cos B, because let me divide each one, stay safe one step, plus cos A sin B over cos A cos B. That is equal to cos B cancels, cos A cancels, tan A plus tan B. I think I remember when I was in A level, we used to have, if ABC are the angles of a triangle, prove this. So there, you have to use A plus B is pi minus 180 minus C, sine of 180 minus C, sine C, tan of 180 minus C is minus tan C. Ooh, they were interesting questions. And they would come up with so many permutations of those. But I think they have stopped doing that these days. So that concludes the lesson on, the topic on, the subtopic rather, on compound angles. But you see, each problem, look, we thought only sin A, only cos B, we're happy with it. Suddenly, the mathematician said, no, you must try A plus B. Now, with all the struggle, 3 lessons you have spent, we have learned everything about A plus B. Maths teachers are not satisfied. No, that is not enough. We want to see what happens if the angle is like sine 2A. What happens if it's a double angle? What happens if it is sine 3A? And later on, okay, you do sine 2A, maybe sine 3A. Then suddenly, if you are doing further maths, you should know tan 7a. It never ends. Trigonometry keeps on coming in to haunt you. But very enjoyable. It's a pleasant dream. It's not a haunting dream. If you enjoy maths, the challenge is fantastic. Otherwise, yes, it's going to haunt you. Have a nice day. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.